No money. Good, oh, from you. Okay. Did you know, children, when I was 10 years old, I used to live in Shepherd's Bush in West London, not that far from here. But every Saturday afternoon, I used to go to Shepherd's Bush Market. And the reason why I used to go to Shepherd's Bush Market was because I was very keen to see what they were buying, what they were selling, but most importantly, what they were throwing away. Because you see, I could not afford a cricket bat. I was living in town, and you could make cricket bats out of boxes which had oranges in them, which they used to throw away. But do you know that every Saturday afternoon there was a very strange man who was selling medicines? He was selling medicines which were called purple tablets. And he said that these medicines were very good for you, because these purple tablets could cure you of any disease. If you had a muscle pain, a toothache, headache, neuralgia, or even nostalgia, this would cure all your diseases. And he said that his purple tablets were very good because they didn't contain any acid. And he said acids were terrible substances which are found in most medicines, and acids burn. He said, I'm going to show you an experiment to prove to you how dangerous acids are. And he said, look, here are some Andrew's liver salts. And if you read the label there, they're used for the stomach. They contain tartaric acid, and acids burn. He also had some Enos salts, and they contain citric acid. Acids burn. And he also had some aspirins. Now, if you read the label on aspirin, it says it contains acetyl salicylic acid. Acids burn. And he said, please watch me show you how you might actually burn your stomach if you take these terrible medicines which contain acids. And he had the man, this was done out in the open air. And I'm going to go out in the open air, as you'll see why, as soon as you must quickly follow me, and you can stand at the door. I'm going to push the door open and let the experiment happen. But he had a large tin lid, and on the tin lid he had some crystals like this, you see, and he put the 2 aspirins there, and he said, when you are ill, you may also have another problem, have a sore throat. And he had some Sanatogen baby syrup. Now this is Sanatogen baby syrup, the lid's down and the label's down, but that's the honest truth. I said, so you may take some Sanatogen baby syrup, and you may also drink some water. I've got a bit of water, a few droplets of water with it. And he said, watch carefully, because I am going to show you how if you take these things, they may actually start to burn in your stomach. And he then poured some water on. He said, watch carefully, because now you may see how this horrible acid stomach may start to burn as you are taking it. And as people watch, gradually, they were watching carefully, it was out in the open there, slowly but surely, something started to happen. And there it is, there it is. All burst into flame, dear children. Now, at that stage, please carry on watching. Now, this is the honest truth, dear children. Now, let's leave it out there to smolder. We want to set fire to you, dear children. And allow me to continue the story, dear children. Allow me to continue the story without a hurry, you see. Now, did you know, dear children, that when all that caught fire and it started to burn, do you know what happened? People put their hands in their pocket and they pulled out half the crowd. Half the crowd. That was a lot of money in those days. And they bought his medicine. Now, I was 10 years old and I was very lucky because to start off with, I wasn't ill. And secondly, I had no money. So I had no problem. Actually, I'm telling you a lie, dear children, because I had a very, very serious problem. I had been born, and it was a mental problem. Shall I tell you what it was? Ever since I had been born, I had developed a secret and passionate interest in fire. And my parents had bought me a chemistry set. When I was 8 years old, my parents had bought me a chemistry set, and I had mixed all the chemicals together to try and make fire. But I couldn't. All it did, it boiled and it bubbled and it changed colour and it made steam and it made the cork go pop. But it was useless. I couldn't do it. And yet here, after 2 years of trying with my chemistry set, this man here was demonstrating something I had never even dreamt of in my wildest dreams. the idea of making fire with medicine and with water. So I decided that I would try and repeat this experiment to see if I could get it to work, you see. So what happened? I decided, I knew where I could get the aspirins, you see, because I could get those in Boots the Chemist in Uxbridge Road. I knew where I could get the Sanatogen baby syrup in Boots the Chemist in Uxbridge Road. I knew where I could get water from the tap, but I didn't know what the magic powder was, what the purple crystals were, you see. And for that purpose, I decided to do some studying. I went along to Shepherd's Bush Library, where there was a large collection of books, and I selected a book which was called Chemistry Magic. And in that book, I looked at all the pictures and all the recipes, and I wanted to see what was possible. Was it possible that that powder might have been that man had on that train? And there was something which did seem to fit the bill. It was called potassium permanganate. Now, I learnt to pronounce those words, and I went to Boots the Chemist in Uxbridge Road, and in addition to the other things, I bought some potassium permanganate. Now, I then went to my mother's kitchen, which was in 44 Stanley Road, Shepherd's Bush, London, W12, and I set up the apparatus, I set up the powders on my mother's kitchen, and do you know, the whole thing burst into flame. I had created the dream experiment of ever having been born, and that was I had used fire, I had used water and medicines to make fire. Now, my dear children, ever since that day, I have been taking part in doing wonderful experiments, and that's what I wanted to tell you about today. You see, I wanted to tell you a bit about the science of chemistry. Now, chemistry is that branch of science which is involved with substances changing into different substances. And very frequently, you can recognize a change because there is a change of color, you see. And here, I am making different substances occur as I pour from one flask into another, and we know that I'm making something different because there is a change of color. And that's one of the ways we recognize a change of a new substance being made. Now, chemistry is a wonderful branch of science, and it's thanks to that branch of science that we have so many wonderful inventions all around us. And we have plastics, we have polymers, we have fuels, we have agricultural chemicals, fertilizers, medicines, food additives. There are a number of amazingly important inventions that have been possible thanks to the science of chemistry. And what I'm doing, I'm demonstrating for you some simple chemical changes, you see. Every single substance that I mix together, every time I mix these liquids together, I'm actually making a new substance, you see. And we can recognize every time what has happened. Now, I wanted to show you here, I got a water which I popularly like to call my magic rainbow water. Now, the reason why I call it magic rainbow water is because it does change color to all the colors of the rainbow, which are red, orange, yellow, green, blue, indigo, violet, as I'm sure you all know. Now, the important thing is this: it is very unusual for one color to change so many times, but this is possible within the science of chemistry. And I'm just going to, and this doesn't always work, by the way. You see, nothing has happened, you see? Nothing has happened. But if we give it a little swirl, then you never know, then you may see a color change, you see? And there we are, we're just beginning, you see, to create a few new substances. Now, the interesting thing is that from the point of view of the science of chemistry, we are actually making a new substance every time, you see. We've gone through yellow to green to orange, and now we'll just make some red color, you see here. Now, dear children, I have to tell you that if this was a proper chemistry lesson, I would be explaining everything, but I'm just telling you so that you can get the idea. And if you remember, after today's experiments, that chemistry is the science of substances turning into different substances, and furthermore that chemistry is most important, then I will have achieved everything I wanted to tell you about, you see, because this is quite a lot to explain. Now, please watch carefully as I swirl this around. It doesn't always change colour. As I said, you can't always predict the colour, but well, this time I'll make sure it changes colour. I'll give it an extra little swirl. So, there we are, and there we are. Oh, bother, it's going back again. Now, these are what we call reversible chemical changes, you see, and sometimes they reverse and sometimes you think it's going to be blue, but I've got to hint that I think it loves yellow. That's its favourite colour. The more you swirl it, the closer it gets to yellow, you see. It doesn't always go yellow, just about got there. So this is very, very peculiar. I can't predict, you see, exactly. But the important point is I am actually making new substances every time. Now, for those of you who said, this is a reaction, this is what this is called. We have it. It's something called universal indicator. And I'm adding acids and alkalis to it to show you all the colours. And there are 7 different chemicals in there, basically, and they're all dissolved. And depending on the ratio of the acid and the alkali, we can get a different colour. But don't worry if you don't understand it. Oh, do you know what I forgot to do? I forgot to do, and that's there, we'll leave that there. I forgot to light my candle at the beginning of the experiment, because I did tell you that my greatest passion and problem in life is fire. And with that view in mind, I wanted to show you some experiments. So I've shown you some experiments which we might describe as magic waters, but they're not, because this is the science of chemistry and substances turning into different substances. I wanted to focus on 2 types of fire which we see, which are not often seen, in addition to a candle. Candles, of course, you've all seen, and people have been using candles for thousands of years. It's not a new invention. And what I've got here, of course, candle is made of wax. They used to be made of oils, etc. And we know from the discoveries of archaeologists that actually people used to have lamps, and people used to live thousands of years ago used to burn similar things like this with a wick and the yellow flame. Now this is a very, very beautiful flame, but from the point of view of chemistry and from the point of view of it being useful, it's what we call an incomplete combustion. It's burning, it's making a nice yellow flame, but you wouldn't exactly cook your dinner on this. You see, it's not enough heat coming out of this flame. Furthermore, this would not be much good in lighting your house or putting a light in your house, because it's only one, and you'd have to have lots of candles, and they would make a very smoky atmosphere, so it's not particularly good. Now, over thousands of years, scientists have been trying to work out how to make, chemists have been working out how to make fuels burn better. You see, ever since man has walked on this planet, we have been burning fuels. You see, the simplest fuel is wood. You burn wood and you have a fire, a wood fire. You can burn paper, you can burn coal, and you can burn gas. And these have been burnt for thousands of years, you see. But it's only thanks to the discoveries of chemists that we have learnt to make them burn better. Now, I wanted to start off with one such fuel that we all use every day. And the fuel I've got here is in a liquid, and if you could read the label, it is called petrol. Yes, of course. Can anyone tell me, where do we use petrol, dear children? Where do we use petrol? Yes. For cars, of course, inside the motor car, dear children. We put petrol into a motor car. But have you ever thought what happens to the petrol inside the motor car? Has anyone thought what goes on inside the motor car when you put the petrol? I'm going to tell you, of course, you mustn't worry. Yes, my dear boy.
It gives it power.
It gives it power, yes, very good. It gives it power. Do you know, though, has anyone ever thought, how does it give the car power to make it go down the road? Have you thought about, shall I tell you, children, shall I tell you? The petrol burns inside the car. It burns inside the engine. And what I wanted to tell you as well, petrol is not a new invention. We have had things like petrol for thousands of years. And it's only thanks to the discovery of the discovery of the chemist that we have learned how to make petrol petrol burn better. Please allow me to show you a simple experiment in which I'm going to burn some petrol for you. I'm going to first of all burn petrol for you in the same way that people have been burning substances similar to petrol for thousands of years. And I have some petrol in here. I'm going to put some petrol on my mat here, and then I'm going to set fire to it with my wooden splint here. You see, so please watch, dear children, and we're going to watch, and there. So there's petrol in here, and we take this out of our teeth. By the way, petrol is very dangerous. You should never take it outside of a car, but as you see today, I'm just doing a little extra, squirt a little petrol. Now, if we set fire to it, you see, please watch carefully how the petrol burns. How the petrol burns. And there it is, you see. Now look at that smoke. Do you think that it burns inside an engine like this? Do you think that could make a car go 100 miles? No. Look at all that black smoke coming off. Look at this. That's not exactly burning fast, is it, dear children? And this is the problem, you see. For thousands of years, people used to know about petrol and other fuels, but it wasn't until the discoveries of the great chemists, the people who studied how substances turn into different substances, that we started to be able to make better use of our fuel. And the difference was really quite amazing. Please allow me to show you another experiment. I have here a tin with a lid. Now, this represents a model of a real motor car engine, right? This is a model, it's not the real thing. But inside, yes, I know you like the smell, my dear boy, but take it easy. A true chemist is budding there. Now, please listen carefully, dear children. Please listen carefully. I have here, now what I wanted to tell you is that every single motor car engine has inside it empty spaces like this, which are called cylinders. That's the honest truth. Every single, you don't have to worry too much, but that is the honest truth. Every single motor car engine has cylinders inside it. And inside the cylinders, we have things which go up and down in the cylinders, which actually make the car work. That's where the petrol burns, inside the cylinders. And inside the cylinders, we have something which is called a piston. Now, I have a real piston from a real motor car engine to show you here. This, you see, fits very tightly inside a cylinder, and it goes up and down in what we call reciprocated linear motion. You don't have to remember that, but that means up and down like that, dear children. You see, like that. Now, the genius of the engineer converted the movement of reciprocated linear motion into circular motion by means of this, which is called a connecting rod. Now, you don't have to worry, but this is what it goes up and down, and this twiddles the crankshaft and all the rest of it. See, but this fitted very, very tightly into a cylinder of a motor car engine. Now, what I've got here, you see, is a can, a tin can, and instead of a piston, which fits very tightly, I have a tin lid. I have a lid, and we can fit this on very tightly. But there's another thing I wanted to tell you about. You see, inside the motor car engine, the petrol has to be set on fire somehow. We have to set fire to the petrol. You can't be lighting it with a match, you see. Can anyone tell me, dear children, how do you think the petrol, it's a very difficult question, maybe some of the older children might know, how is the petrol set on fire inside a motor car engine? Yes, my dear. Not by the air in it, my dear. No. How do we set it on fire? How do we make it burn? I'll tell you, it's a very difficult. We use a spark, an electric spark, like a miniature flash of lightning. Children, have you seen lightning in thunderstorms? Some of you may have done. It's very frightening, and it makes a huge noise. And you know, when we have thunderstorms and lightning, I'm so terrified that when I was small, I used to get under the bed because I thought that the whole house, because it was very dangerous. But inside a motor car engine, we set the petrol on fire with electric sparks. You don't have to remember this. Now, what I wanted to tell you is I am now going to show you what happens when we set fire to petrol inside this tin can. Now, if I were to ask any of you, what's inside this can, you see, you'd be entirely correct to say that there's nothing. There's nothing. Because you see, when I bought this can in B&Q, in the Cricklewood, it had an undercoat in it. Paint, you see, paint, white paint. But there's no paint in here, it's all gone. But from the point of view of burning, and from the point of view of making petrol burn better, it is full of something else. Do you know, I'll tell you, dear children, it's full of air. You can't see it. It's all around us, air. There you are. You can't see it. And there's nothing to see. But that is honest truth. It's full of air. Now, you see, people didn't realize that. People didn't realize that this was important. But it was the science of chemistry. And it was the chemists who about 300 years ago said, this is important. Please allow me to demonstrate. I am now going to squirt inside my petrol can, which notice has a hole in the bottom. Can you all see the hole, dear children? Yes? There's a hole in the bottom, and I am going to set fire to the petrol, not with an electric spark, but with my spring. I'm going to take out the same volume of petrol that I had last time. There we are, the same volume of petrol which I had last time, and I'm squirting it inside the can, and I'm now going to put the lid on the can. Here we are, the lid is now going onto the can like this, and I'm putting the lid on very tightly, because inside the motor car engine, the piston fits very tightly in the cylinder, and here the lid fits very tightly into our can. Now I'm doing something else which is very important. I'm now warming up the can with my hands. I'm just making it a tiny bit warmer, and I'll tell you why. Because when you warm up the can, then the petrol inside has a very interesting change taking place. It's not burning, it's not making a new chemical. Does anyone like to guess, children, what the petrol is now changing in a way which is not chemical, it's a physical way? What's it doing? Have a go, go on. It's not on fire, no, my dear, it's not burning, yes?
Turning into smoke.
It's not turning into smoke, but that's a very good guess. You're almost on the right track, man. It's certainly turning into something. It's turning into a gas. Is now the word we use, children, it's evaporating. You see, the petrol, did you see it was a liquid? Did you know this? This was liquid petrol I put in here. Did you see that, dear children? This is what we call a liquid, yes? And these are liquids here. Now, what's happened to the petrol here? It's no longer a liquid. It's now in the form of a gas. And good smell of petrol. Now, I know some of you are like, this is not good for you, but it smells. But we say that the petrol has evaporated. The petrol has turned to evaporate. Now, because it's evaporated, it is now mixing with the air which is there. Please allow me to show you, children. I'm now going to set the petrol on fire. I'm going to set it on fire, but with our little hole at the bottom, you see. So please watch carefully and see if you can notice the colour of the flame when I actually set it on fire, and see how it burns, and see if it's similar to the one you saw last time. And what we have this time is a completely different type of burning. Did you see that, Julie? Now, what we had there was what we call an explosion. The petrol burns much more rapidly. The petrol burns much more. Did you see that? Yes? Now you see, this was easy to demonstrate like this and tell you, but it took thousands of years for people to discover. And the people who discovered were the chemists. People were working, trying to understand what makes things burn better, you see. Now, thanks to this, of course, now you can certainly imagine that making a car go 100 miles an hour, because the petrol burns, in a nutshell, very quickly, very quickly. First time it burned slowly because it was a liquid burning in there, but the second time it had already turned into a gas, and therefore it burned much more quickly, and an explosion took place. Now, in a real motor car, that would have pushed the piston, you see, and in a motor car engine, this burning takes place thousands of times per minute. It goes very, very quickly, up and down. Unbelievable. That is the achievement of chemistry, making fuels burn much better. Now, dear children, I wanted to tell you something else. The chemists also discovered that actually in the air around us, it's not all of the air that makes the fuels burn better, but air is actually a mixture. There is more than one thing present in air. It doesn't look like that. And for thousands of years, people just assumed that air was a single substance or an element. But they discovered by about 300 years ago that actually there are two main gases present in air, one of which makes things burn better. Now, is there anyone here who might know what those two gases might be? Yes? Nitrogen, very good. Nitrogen is the main gas in air. About 4/5 of the air is nitrogen. Now we have another child.
Phlogiston.
The other one, phlogiston, yes, no. You know, today, dear children, it was called phlogiston. The other gas, I'll tell the children, it's called oxygen. Have you any of you heard of oxygen? There you are, you see, good, well done. Well, oxygen, dear children, that is the part of the air which we can't see, but which actually makes things burn better. And what I wanted to tell you about, chemists, by the end of the 18th century, about 300 years ago, chemists had discovered that if you actually try and make a fuel, combine with oxygen, add oxygen to the molecules, then the fuel will burn much better. Please allow me to show you. I have an experiment here which is incredibly boring, an amazingly boring experiment, but I believe you should be shown this boring experiment in order to see a less boring version of it later on. Now, I have here, children, cotton wool. Cotton wool is here, and what I wanted to say is that cotton wool, there it is, look, you've all seen. It is wonderful. It is wonderful to touch cotton. It grows on, and it's used for cleansing, for cleaning, you see. And clothes are made with cotton. You see, many of you have cotton vests on, and very, very gentle indeed. Now, cotton, of course, grows particularly in hot countries. India and Egypt are very famous for producing large amounts of cotton in their very warm, moist climates. And cotton has a very, very delicate touch. That's a lovely cotton shirt there, my dear boy, you see. And you can touch the cotton wool and see how delicate it is, you see. Now, dear children, no one would ever think of burning cotton. It's a pointless exercise. But I'm going to burn some for you because this is what chemists did. You see, chemists were experimenting to make better fuels by adding oxygen atoms into the cotton, which is called cellulose. That's the chemical name for cotton. Please allow me to show you. As I say, it's very boring, this experiment, but you need to show the boring experiment in order to appreciate what happens once the chemist has given it some attention. So, we're going to take here a cotton, and I'm going to set fire to it. It's an entirely boring experiment. Please watch carefully. Regardez attentivement. Et voilà. There it is. You see, it's burning like a piece of paper. Like a piece of paper almost, and it burns quite slowly in air because it is only surrounded by air which contains about 1/5 of oxygen. So that, you see, is a relatively boring experiment. Cotton, by the way, is made of the same sort of chemicals that paper and wood are made of, and so forth. Now, what I wanted to tell you this. In the middle of the 19th century, about 150 years ago, scientists started experimenting and trying to add extra oxygen to cotton to see if they could make it burn better. Now, I have here a piece of cotton wool which looks almost exactly the same. And in spite of me telling you at the beginning that chemical changes always change colour, this is an interesting example where the colour hasn't changed. This is what started off as a piece of cotton wool, normal cotton, but using chemical means, I have added extra oxygen. And we could do a very simple test. You see, if I weighed one of our original pieces of cotton wool here, that would weigh 1.1 grams. That was roughly the mass of this, 1.1 grams. However, if you weigh one of these, it's 1.4 grams. An extra 0.3 of a gram of oxygen has been added, in addition to a bit of nitrogen as well. But I'm not going to go into great details. I would, in essence, we've added extra oxygen. Now, dear children, please watch carefully, because when I burn this, you'll notice it burns quite a bit differently from the first piece of cotton wool. So here we go, as you see, an almost instantaneous flame, you see. Now, there is no smoke, etc. Now, the reason why this burns so well is because what's happened is that the extra oxygen that the chemists have added has made it burn much better. And this was another great triumph of chemistry about 150 years ago. Now, what I wanted to tell you, that actually this type of cotton which I have made is actually a high explosive. It's very dangerous, and it's used in artillery and guns. It's used for blasting mines and so forth. And I wanted to show you an experiment in which we make use of this property of it burning very rapidly. Now, ideally, I should show you an explosion. But explosions with gun cotton are far too dangerous because it would blow us all and kill us all. However, I can show you I can show you a type of experiment which is less dangerous and which we call a propulsion. And I have here a specially devised type of primitive cannon which I wanted to introduce you to. Now this is essentially, you know when you see lovely fireworks in the sky, dear children, have you all seen fireworks at night? Well, you know when you have the lovely ones up high up in the sky and then lots of flowers shoot out and coloured flame, they're projected from these sort of things. This is called a mortar, and it's a mortar which fires shells into the atmosphere and they catch fire. And I'm going to show you this one, which I made specially to show you for today. Now, I am not going to, this is not a firework mortar, but I'm going to fire out some ping pong balls. You see, I here have some ping pong balls, and I have, this is shape, it's like a type of cannon, but you see I haven't put a hole at the bottom here. There's a hole there where I'm going to light my fuse. I'm going to put a special fuse in there, and I'm going to let the fuse light the gun cotton which is at the bottom. Now, so we're going to fold up the gun cotton here. We put it inside our gun cotton cage, which is this piece of metal, and then we add a piece of fuse to it. Now, I have a small piece of fuse here. I have a small piece of fuse here, and we put the top on there, and we have to make sure this goes in here. And I'm going to now put this here and drop it in there. Oops a daisy, silly Szydlo missed. Right, here we go again. Drop it in. There we are, it's gone into the bottom. Now, the next thing, we put our fuse powder in there, and then on top we put 4 ping pong balls. 1, 2, 3 and 4, which is what we're going to fire today. We then set it up in our special mortar, you see. Now, I could do this indoors, but I'm actually going to do it out of doors today because it does make a little bit of smoke. So come and watch, children, through the door, and we'll fire off our 4 ping pong balls into the field, into a football field. And then we can come outside here, children. Can you tell me this? If you can catch a ping pong ball, then it's finders keepers. So anyone who can find one afterwards, then you should. They don't go that far, but I think you'll have rather fun trying to get them. So we're going to tilt our mortar here and just tilt it back a little bit there. And then we're going to aim in that direction, and you'll be more than welcome if you can find the ping pong ball or catch one. Now, just stand back a tiny bit further, 2 steps back. That's good. You don't need to be too far. So we're going to set it on fire. It does make a little bit of smoke, children, and it does make a little bit of a bang. So please, if you're too afraid, perhaps you should run away. Now, there we go. There's our fuse. And watch carefully. And then, once you see them go, see if you can catch them. They're all yours to keep. Oh, there we go. Now, where are the ping pong balls? Oh, dear. Oh, there we are. So, that was quite a loud one. I'm afraid it destroyed the ping pong balls. Oh, dear. That was a bit too much. Right, let's go back indoors, children. No, that's yours to keep, my dear boy. You can keep it as a...